We are Mike and Jeannie, and we restore old houses. In 2021, we moved to South Carolina and bought a 120-year-old Victorian house. Follow along as we put the polish back on this Victorian masterpiece. Welcome back to another episode of 1834 Restoration House. If ever there was a miracle juice, it has to be this stuff. This is deck cleaner. Now they claim that if I spray this on to this old ratty looking gray weather beaten deck, that 10 or 15 minutes later I wash it down and it's going to look like new wood. Maybe not quite that good, but much better than what it looks like right now. And let's see how it goes. So I'm hitting all the wood that's old and weather beaten. It has a kind of a bleach-like odor. Ooh, yeah, it definitely has bleach in it. Makes me wonder if bleach water would do the same thing. This wood is so old and dry, it's just soaking it all up. It smells like a public swimming pool in here. Very strong chlorine. We've seen a couple places already where the color changes from being wet. I hope I have enough here to get the job done. Well, this will definitely kill any living thing that's on the wood. Any microorganism. That is some strong bleach. Kind of got us wondering if we just used straight bleach, would it do the same thing? Okay, I'm about to run out here, so I'm trying to hustle it and get done. There won't be enough left to do the posts, unfortunately. Okay, the container said put it on, wait 10 minutes, and then spray it off. So here it is. Let's see how well the miracle juice works. Well, I'm not sure how miraculous that is. I'm not really seeing a color change there on the gray wood. Well, my initial impressions are too good to be true. I am not seeing a change here. All that gray blackness there is still there. It says you don't have to scrub it. But just to be fair, let me give it a really hard hit. So I'm going to set this on this full blast and see what that does. Well, I don't know. Yeah, just not seeing much of a change here. Well, today is a really exciting day. The utility company showed up and they're trenching in the utility for our new power system. So we'll get you a couple of shots. Here you can see the beautiful red clay soil. And they've trenched all the way across the yard, almost over to the pole. And they have to dig down a certain number of inches, according to local codes, to bury the conduit. So trenching typically goes anywhere from 18 to 36 inches, and he says that 18 inches is the minimum, so I think they're probably going to try to go more like 36. And what they're doing now is pulling the cable into the box, and it's run through a length of conduit. That was pretty simple. And there goes the lock ring. Right there, he's just cinching the lock ring down. Now he's bending the wires around so that they can go into the lugs. So you notice that we put our lugs on the bottom, and he's doing his on top. It really helps to have strong arms. The cables they use are called direct burial type, and so they literally just lay them in the ground and they pop them up on one end and pop them up on the other end. Then after that they can just go ahead and fill the trench back in. Makes for a quick, easy installation. They were very apologetic about messing up the yard, but I told them not to worry about it. It is what it is. So he has some monster cutters that are used to clip the wires. Since I don't do this kind of work every day, I certainly don't have that tool and have to do things the hard way. There's the obligatory red tape. Although he's putting on both, which is kind of interesting. It looks like he's putting the tape on all three. It's hard to see right now because of the camera angle, but he's over there cutting the insulation off with some really sharp cutters. It's always fun to watch a skilled backhoe operator. The things they can do and the precision that they have is amazing. Come springtime, the grass will grow back and it'll be just fine. Okay, the lineman, now he's taking out the lugs, or loosening them up. Notice tips of the wires are completely slathered in that conductive grease. Using his calibrated arm, it looks like he's going to go ahead and cinch that down. After building a lot of these, I'm sure they know how to get the right tension. Now there's some skill. Now he put the blade down and he's backing up. That's a really good way to smooth out soil. I'll show you in a second what it looks like when he's done. All right, let's take a closer look here. Look how smooth that is. So he'll go over it again a couple of times, make it perfect. Now he's doing some really fine work there, just really trying to smooth it out and make it look perfect. So count yourself lucky if you got a man who knows the excavator. What he's really doing here is he's taking the excess dirt that was dug out and spread out, and he's pushing the excess right back into where the trench is. And I suspect when he gets it all there, he'll just push it down with the excavator bucket and try to make sure that most of the dirt goes back where it came from, instead of being spread out in the yard. I just have to show off how good this excavator work is. Look how smooth that is. He put it back in perfect condition. The next part of the job involves digging out just in front of the pole. And so they're going to bring that underground cable up right under the pole. And as soon as they get there, they're going to put it into a conduit. But it looks like what they're doing now is taking out the old lighting conduit. We had the lighting removed recently, and so that conduit really doesn't do anything anymore. So it looks to me like they're going to bust it up and take it out of there. Let me just show you the top here where that goes. So it goes up here to the top, and I don't know if you can see it very well, but the wires are basically just chopped and they go nowhere. It doesn't really show up here from this angle. Unfortunately, if you're dealing with the ground, sometimes you gotta get out the hand tools and just dig by hand. The heavy digging has begun. So somewhere under all that he's digging is an old electrical cable which goes out to the light circuit. Well, it's no longer connected to anything, so there's no danger here. But I think he's being real careful to try not to dig it up. Once he gets down to the proper depth, then he'll back up and start taking scoops out, going backwards. So the buried cable that they put in so far pops out of the ground somewhere right behind the excavator, just off camera. Here it is from a different angle. You can see the enormous spool of cable that they brought with them, and you can see where the wire goes into the ground. So he has to dig all the way back to that point and liberate that so that they can lay the rest of the cable. Now he's reached the proper depth and he's starting to pull the trench back towards him. We have a lot of clay soil here in the south. Okay, what he did there was just collapse the wall between the first trench and the second trench. Now he's digging out the dirt that came out of that. There, he just collapsed it again and is now picking it up. So now the two trenches are connected together. And once he gets done there, he'll back out a little bit, and then they'll lay the cable in the rest of the way. Here's a different angle, and you can see where the two trenches are connected together. So it goes out and then bends about 45 degrees off to the right. Nothing more can happen until he gets finished with that. How would you like to be that strong? He raised it up so that they can spool off as much cable as they need, and it'll just roll. Now, just to give you an idea where they're headed here, they have to go all the way down the trench, and then they have to get into a conduit and go all the way up to the top of the pole. So they're going to have to pre-cut as much as they think they're going to need, plus a few feet extra. And then once they get that cut, they'll slip it into a conduit and mount that up to the pole. One of the great things about doing this kind of an installation is that squirrels can no longer run up to the house. And as they pointed out to me earlier, squirrels can't bite the wires. They were telling me earlier that the squirrels will actually bite in the wire and start gnawing away at the aluminum. And they've actually been known to cut all the way through the aluminum. And if they cut one phase, it's not a big deal. They can fix that. But if they cut through the neutral, it can actually cause the two phases to backfeed each other, and you'll start blowing things up in your house. Okay, so you saw them cut the cable. Now the spool is out of the way. While one workman puts the cable into the conduit, the other is starting to backfill the trench. Working together as a team, the two men can get a whole lot done in a short amount of time. He's now fastening down the first section of conduit to the utility pole. But you'll notice the cable is still sticking out the top, so he's going to have to take another section of conduit and put the cable into the conduit and then slip it into the end bill and glue them together. As he's going up, it looks like he's pushing the old conduit out of the way, and we'll probably take it off. I just spent a few minutes talking to the guys, and we talked about excavators and tractors and trucks and utilities and things. It was fun. Apparently there's a bucket truck that's coming. It's on the way, and it'll be here shortly, and they're going to use that to get up high rather than using a ladder. The guys were ready to jump on the ladder and just get it done, but apparently headquarters thought differently, and they want to send a bucket truck over here, so that's fine. A little bit earlier, the neighbor came over and talked to the guys, and apparently she was concerned that they would be digging up her yard because they had striped it for a utility locate, and there were flags running across the yard, but they reassured her that no, they weren't going to tear it up. It was just simply a precaution so that they would know where the wires are. That way they don't accidentally hit them when they're digging. The utilities take this thing very seriously. Right now they're just cleaning things up again and regrading. All the burial work is now complete, and everything else has to happen above ground. I told the excavator driver that I was really impressed with his grading skills, and he says, "You being facetious?" I said, "No, I'm serious." He says, "Oh, okay, thanks." He said this was actually his best job that he's ever done, so that's pretty cool. Come springtime, the grass will grow back up, and you'll never know it was there. right, there goes the spool. Quite possibly the cat. He'll probably come back and tidy up just a little bit, or maybe just do it by hand. They have to get their truck out of the way so the bucket truck can get in here. All right, he's going to try to get up that ramp there with that spool of wire. Nice. And there's the conduit. What he was doing there was laying the conduit up there, just trying to get an idea of how long the thing needs to be. And then he made a mark, and now to bring it down to the ground and cut off the excess. Okay, he's got his Sawzall, and here we go. Beautiful. If you're new to the channel, we put in this new electrical system over here on the left to replace the old electrical system, which you see on the right hand side there. The old one there is about a 100 amp service, and the new one is a 200 amp service. And that's a significant upgrade over what we had. That black coil right there, those are electrical wires which go into the house, and they pop up inside the breaker panel there, and they show up on a 100 amp breaker. So what's going to happen is when we get the electricity cut from the old system and they power up the new system, that breaker that's in the new panel will then supply power back through that to the old panel. And that way the entire house will still be powered up. And then over time those circuits can be walked over one by one to the new panel. Now we've had a couple of people over the last several months ask us, why in the world would you put an electrical panel on the outside of the house? Well, two reasons. A, it was already there. B, we don't want to put a breaker panel inside a historic house and disturb the historic fabric of the wood and the plaster. It would look really ugly. And we've had some people say, well, why don't you put it in the basement? Well, the answer is that window over there is just a crawl space window. We don't have a basement. So all things considered, it really made the most sense to go ahead and put the new panel on the outside of the house just like the old one was. Is it ugly? Yeah. But I'd rather have the ugly here on the back side of the house where it's not very visible rather than be inside the house in the historic structure. Okay, so the cable is now in the conduit and the excess has been chopped off. And they're just going around just trying to break up the dirt a little bit just to make it a little bit better. And we'll probably have to come in here and throw some grass seed on it. Looks like the bucket truck just got here. So they're going to go ahead and pull that in here, and then they can make the connection up top. This is what they call a bucket truck, and you'll see why in a second. The first thing they're doing is leveling the truck because they don't want it to tip over. So it has special suspension and jacks. If you've never lived in the South, you missed out on a certain level of friendliness from the local people here. Even workmen who are busy will take a few minutes to say hello and just talk with you. It's really nice. Okay, so he's getting in closer here. I think it's time for us to do the same. The man in the bucket is really close to 240 volts AC current. The wires right next to him are definitely live, and he's going to go up there and work on them hot. Not to worry though, because this isn't extremely high voltage. Okay, we have a quandary here. The conduit and the cable is laying on the ground. So how do we get up to where it needs to go? Spiked boots and a climbing harness.
When you want me to go eat lunch with him, I don't know if I'm going to have time. I say, I don't have a clue on it. Don't think?
Those are special protective gloves that protect against electrical shock.
He hadn't had any problem. You had no lights flickering, nothing in the house, had you?
Doing good, man.
I got all day. I don't care how long you take. Don't rush it. Don't rush it.
I ain't rushing
You're
nothing.
fine. You're fine, but take time. We waiting on you.
I'm lying on the post. I said, you go by my
Right.
Get lying on the
It's your
post.
hand. 1, 2, slide. 1, 2. 1 with your left. Not big. Hey, 6 inches. 2. Slide.
Lean up. Lean up.
1, 2, slide.
I have to be so fucking hot on the day after. Why you always talking shit? Don't you complain? Why you always damn laughing, dog? This bucket needs a chair in it. Let me sit down and wait.
There you go. There you go. Your leg's gonna kick you in the pole. It is. Slide. Lean and slide. That's more. I got it. Trust your hooks, okay? When you trust your hooks, you'll be fine.
It needs to say winter, because this starts happening in the summertime. You ain't gonna catch me on a pole.
Oh yeah. Oh yeah. You gotta help me in sometimes. You do. All you gotta do is lock that knee. Lock it back. There you go. Right. Keep them knees locked down. Look. If you like this, you're going to come straight down. If you like this, you're going to go straight down. Look where you got now. You like this. Good. Put it on in. I actually got.
Okay, the old conduit is out. And now he's free to climb up.
right now, your foot, you're gonna get split in between the two riders. You might work on that.
The guys were prepared to do this using a climbing belt and ladders, but one of the senior linemen came along with his bucket truck, and it's really making the job go faster and safer. Okay, the meter is out. Power to the house is now dead.
Alright, no matter how you cut it, you just cut it. You ain't got to worry about this all day. Let the nick it quiet. About the stack. He said the stack's coming off too, so. Markman cut both sides. They fall off the cell. Yeah. Got nobody. I'm gonna teach you something here, ain't I? Boy. I'm gonna teach you something here.
What you mean?
I'm gonna teach your little butt something here.
Both sides?
Yeah, that's the easiest way to do it right there.
I'll try it off.
I'm gonna teach your little tail something here.
I was gonna do it in the first place. You said fight it off. I said, oh, hell no. If I'm pulling that or pull, I ain't fighting nothing off. Your ladder or his?
Mine. We gotta get him back on now.
What?
We gotta get him back on now.
Who back on? Him?
This man.
Oh, he said he'll run off generators for a little while.
He ain't gonna run off nothing. He won't run off that meter. Them mattresses hands now.
Huh?
It's them mattresses hands now.
Just fastening down the last of the conduit. For the first time since this house was built, we now have 200 amp electrical service. And there's no way the squirrel can run across that wire anymore. So these are the guys who do electrical work day in and day out, and we really appreciate everything you do.
Appreciate it.
You know, fair weather, foul weather, you guys are out there busting it. They did an awesome job here putting this underground service in. So while you were up there, you found some kind of problem with the wire overhead out to the street. So
neutral, the squirrels have chewed it up. It's got about 34 strands completely gone. It's probably about 2 of them just holding with that steel core. It's the only thing holding it up.
if your lights are flickering, I guess is that we need to call the utility and report that, because there could be some kind of problem.
Yeah, it could be something on our side where we could fix it free of charge towards you, or which we take care of everything from the source to the meter.
To the meter, okay.
everything, we take care of that.
Now, if let's say a squirrel were to cut all the way through that neutral, what would happen?
You'd lose your neutral, it'd revert both legs. Instead of having 120 volts on one leg, you have 240 on both sides. It'll burn up all your appliances. It'll burn up everything in your house.
Serious business there. So if your lights are flickering, definitely call your utility and have them check it out, because it might just save your house, might save your appliances. So anyway, all right, well, I'll let you get back to work. I appreciate everything, and thanks for doing an excellent job there. And by the way, your skills there on the excavator, top notch.
That one's a lot better than mine.
All right, have a good one. Well, that was great. Utility guys are the best, I gotta say. You know, they care about what they do. They're very passionate about it. They enjoy it. And I could see a very strong camaraderie between these guys here, and they were helping each other out and coaching each other along. They're also very thorough. So in addition to finding the chewed through wire that came from the power pole, they also noticed that there was a voltage drop on one of the phases. And so they're across the street right now. You might be able to hear the sound. They're over there across the street checking out the transformer just to make sure that everything's okay. But their plan is to come back and run a whole new squirrel-proof cable from the transformer back over to here, and then everything will be great. Next door neighbors have no idea that this is all transpired, but they're going to get a benefit from it because they're also on our circuit. Now, this is dead, completely dead. Our whole house is completely dead. We have no power at all. So what I have to do is reach in here and disconnect the old, and they did confirm that this is 100 amp service. So I'm going to go ahead and take these out. Maybe. So there's the A phase, the B phase, and ooh, that feels crusty. When I move it, it kind of cracks a little bit. Okay, the neutral has to come off too. I severed this cable. This is the cable that went from the meter box to the breaker box, the old breaker box. And now I'm going to start walking this old cable out of here. All right, here we go. These wires have probably been here since the 1960s. And this is the first time in, I don't know, 80 years, whatever it is, that there hasn't been any power in them. They're finally retired. The old connection is now severed, and now we can take this entire meter box, masthead, and all that stuff off the wall. That can go away. This, however, has to stay because the entire house is still running on this panel, and what we have to do is offload the load from this panel to the new panel, one by one by one. But in the meantime, this is the power from our new panel, which will power up the old panel. So this then becomes what they call a sub panel. I'm going to go ahead and feed this through. Easier said than done. This one circuit here is in the way. These wires look terrible. They are cloth wrapped, and there's some kind of rubber goop on there. It looks like they may have frayed and then somebody covered them up with goop just to keep them from shorting out. This is definitely sketchy stuff here. All right, well, let's continue moving this in. See why these junction boxes are so cool. You can just roll it right in. It takes a little effort, but here it goes. So I guess I'll take this one first. If I pull them one at a time, they usually go easier. Okay, let's go up rather than out. Oh man, that's stiff. It's nowhere near as stiff as the big ones were, though. All right. Okay, I think that's good enough. I'm going to just push the rest back in the box. I can go ahead and put the lid back on there now. Okay, before we hook up the new panel, I'm going to check the voltages on the new panel. Now, the utility company, they did this already, but I'm now responsible for it, so I need to make sure, doubly sure, that it's correct. So I'm going to measure across neutral to the hot side. The A phase is 120.5, and I want to see 120 over here as well. I see 125.3. So there definitely is a difference between the two voltages, just like they'd said, but they're going to come take care of that later. Now, if I go across the phases, I need to see 240 volts, or thereabouts. And I have something. We have overload. You know why? Because I'm on the 200 volt range of the meter, it says, that's too high. So let's kick it up to 600. Now we should be able to read this correctly. And we have 245 volts, which is pretty close to what we want. Okay, here's the neutral. I'm putting it into the neutral lug. This old General Electric breaker box, I'm sure it was really good back in the day, but this thing is so tired. So tired. Let's put the B phase in here. You know, they said they don't make things like they used to, but in the case of electrical systems, they are definitely better today than they used to be. I want that thing to be good and tight, because there's no telling how long this will be in place before it's taken out. All right, that feels good. And now the A phase. One thing they've really improved on is, instead of using screwdriver type bolts here, they switched to hex head bolts. And by hex head, I mean the kind where you stick a hex wrench into it. Okay, one more check here to make sure they're really good and tight. These wires are copper, so I didn't have to put any treatment on them. No conductive paste or anything like that. All right, so neutral is connected to neutral. A phase, B phase. All of the original wiring is back into its position like it's supposed to be. So, what do you say? I'm going to walk over here and energize the main panel right now. Ready? This panel is now hot. I'm going to energize the breaker to turn that panel on. That panel is now on. The house theoretically has power. So let me grab a hold of this thing here and give it a quick test. All right, so going from neutral, A phase, 120 volts. Neutral to B phase, 125 volts. Do this carefully here. A phase to B phase is 243 volts. So everything is working perfectly. The house is now completely 100% on the new power. And none too soon, because our camera battery was just on the verge of dying, but now we're on shore power and we can keep filming. So the scope of the project was underground service, new breaker box, and new meter box, and cross connect to the old system. And so that's the scope of the project. We need to complete this now and get the final inspection, and that'll be the end of the project. So I'm going to take this little piece off of here. This is reserved for the master breaker. But the main reason they left it in was that this was a main lug breaker, remember? It didn't have a master breaker when we bought it. We had to install a breaker kit. But when you install the breaker kit, that means you have to knock out the knockout so the breaker can stick through the panel. It's really loosened up here, so it should pop here in a couple of seconds. There we go. Thanks to metal fatigue, we now have an opening for the main breaker. But there's one more thing that we need. The breaker to the sub panel is a double breaker, which means that we need a double knockout here. So I'm going to go ahead and get that going. After a couple of times, it really gets loose, and I can just do it by hand, and falls out just like that. So long, breaker box. It's been fun. Okay, that's not fitting quite like I wanted it to, so we have to troubleshoot this a little bit. This breaker looks like it's down, slipped down just a little bit. So what I need to do is get some tools in there, loosen it up and push it up ever so slightly. But now it's electrically hot. So I got nitrile gloves and leather gloves. Double layer of protection there, because we don't want to get shocked. The main breaker is on. So let's go ahead and turn that off now. So that means that the entire bus bar down here is dead, which theoretically means that whatever I put this wrench on is also dead, but I'm not taking chances. So I'm going to go ahead and loosen this up a bit. Being careful not to touch ground. All right. Well, that's not the only problem. This corner here was riding too low and it wouldn't fit in the box. And when they punch these out at the factory, they probably have some kind of a stepping machine which goes punch, 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 punch. When it got to here, somehow the panel got kicked sideways at the last punch, and now it's offset and it's interfering with the fit with the breaker. So I'm going to have to take a file and cut that down a little bit. You know, I've had really good luck with Square D in the past, and I'm really surprised that there's so many fit problems with this one particular unit. So I'm just hoping that that's not a normal thing for them. So let's go fix this real quick. If you look carefully, you can actually see how it kicked sideways. Okay, one more time. Well, it's getting better, but it still doesn't feel quite right. So I'm going to have to relieve more of this out of here. Well, I had to do all kinds of gymnastics to make this cover fit on here. It's clear that when it went through the manufacturing process, something went askew on it, and so this inner panel doesn't fit right. If any of you work at Square D Electric and know how to fix this, please let me know. Let's see if I can get the screws to fit. Even the screws don't want to go in correctly. Well, you know, usually I have good things to say about Square D, but this one here, that is just not working right. And the screws won't get in the holes, and they feel like they're about to strip out. Very disappointing. Let me pull this back off and see if they'll fit properly without this on. There are no threads in these holes. There's no threads in the holes. Well, that's why they wouldn't go in properly. Is this normal? I guess you have to cut your own threads, but good grief. No, that doesn't feel right. You shouldn't have to cut your own threads. I think somebody at the factory was having a bad day because these two tabs right here, this is where the cover screws down to. But this tab here is correct. This tab here is too far back in that way. And they're just simply spot welded. And I don't know what happened that day, but this tab is way too far back in the case. And it's unusable. So I'm taking this out. Just, you know, I'm not one to complain, but there's just too many things wrong with this box, quality control wise. All right, I'm going to see if I can cut some threads with these screws. Well, that worked. Well, there we have it. So these two can go in. This one here, there's just absolutely no way because they welded the tab on in the wrong position. Okay, well that's as good as it's going to get for now. There's two more things that we need to do before we call this good. So right up here it says mains rating. How many amps? 200. So I'll go ahead and write 200 in there. And then breaker 1 and 3, because they're ganged together, this is going to be sub panel. And I'll just put a little curly brace here just to show that they're together. That's it. We're done here. Let's take our tools and stuff out of here. There's a lot of debris, so I'm going to go ahead and pull this out at the same time. going to go ahead and close this. Nope, wait a minute. First of all, I have to put this back on. And then close it. Sure. There we go. Now that we've done the new, let's take care of the old. So I need to disconnect this box right here, and then if you look up above there, you'll see the weather head is held on by a bracket and 2 screws. So I'm going to release those and release these, and then the whole thing will just come right off the wall. Apparently back in the 1960s, they would put a ground right at the neutral inside the meter box. Well, we don't do that anymore. So this needs to come out. Okay, that takes care of that. And then they had some other ground coming over to here. That's the cable television. So we do have a problem in that this box has no ground, apparently. The ground was made through the neutral at the meter box. We don't do it that way anymore. So what we're going to do, we'll fix that in a minute. Let's just get this out of the way and get this off the wall first. I got my tool. Can you come down here and grab that box?
Yes. Okay.
Okay, now twist it out towards the west. All right, now put it towards the wall.
Okay.
It's just about there. Push it towards the wall just a bit. Okay, it's free. Okay, it's all yours.
All right.
When the guys worked on this earlier this morning, they dug up my ground wire between the 2 grounding rods, and they need to be buried, so I'm just going to go ahead and put it back in the ground. The modern electrical system has to be grounded. The system here, which was put in back in the 1960s, was capable of being grounded, but it doesn't conform with modern grounding standards. But still, it has to be grounded. And the way it is right now, there is no ground whatsoever in this box because it used to go in through the meter box. So what I'm going to do is locate the ground rod, which is down here on the ground, And I'm going to take a new piece of copper and I'm going to run a whole new ground wire up into this box and connect it up. So before we go messing in there, let's kill the power to it, which is probably going to kill your camera there. Okay, I found the ground rod, and what I need to do is undo this screw right here. Luckily it hasn't rusted itself silly. I'm going to go ahead and take that out a bit, and then this wire should pop out the bottom, which it did. Okay, I'm going to bend the end over using this box to pull on it, like that. So you just use whatever you have handy. Okay, I'm just cleaning out the hole and knocking some of the dirt off of here. And I'll take our new ground wire and put it right up through here. Maybe. There it goes. And tighten it all down. Okay, now I want to put a bend in it right here so it can go up the wall. And then we'll just go right straight up, uncoiling as we go. Okay, so my target is going to be this lug right here. So what I'll do is come in the side and then I'll change direction and then go uphill. So I'm just going to try to estimate what that looks like. Probably about like that, and then we can just tuck any excess away. So I'm going to go ahead and take my cutters here and nick it really good. I'm not going to try to cut through all this hard copper with these because I don't think they can handle it. So I nick it good and then just start bending back and forth. And that forms a weak spot, and then eventually it just gives way like that. All right, so let's go ahead and put that through the hole. Pull it through like that, and then I'm going to bend it back on itself and make a loop out of it. Bend it again so that it can go up into the lug. All right, I'm just going to go ahead and take this lug out a ways. I'll push the ground up inside there. Hold it steady where I want it and then crank down. I noticed that this neutral here is a little bit loose, so I'm going to go ahead and put the screwdriver to it and just tighten that back up again. I'm not sure why it was loose, but it was. And now it's not. All right, let's put the cover back on. Close it up. Great. So there's our ground. And I'm going to go ahead and put the soil back on it. Okay, you think we're done, right? Wrong. We have one more thing to do. This is the ground from the cable company, and they're supposed to be bonded to the electrical ground, and we just took that away. So let's fix that real quick. They provided us with this nice little clamp here, so I'm going to take that loose, and I'm going to put it down as a loop like that. That way any water that gets on it will just drip right down. Now, I take this and I lay it up against the ground wire, and then I start tightening it up. And what this thing does is it clamps the two wires together tightly. Okay, that takes care of the cable system. It's now bonded back to the ground system with a brand new ground wire. And our sub panel has its own electrical ground to a ground rod just as it's supposed to. So let's go ahead and kick it on. I don't hear any strange noises or see smoke, so I think we're good. Let's just give it a quick look over and see if there's anything else to do. So that's okay. That's gone. That's energized. That's all on. And ground wires are buried. Do not remove this ground wire. Well, I guess I better put that back on. Okay, much better. That looks good. Okay, where were we? We're just checking things out. So that's grounded, that's grounded, that's grounded. Everything is buried. Everything is turned on. Let's check the meter. All right, looking at the meter here, everything seems to be okay. This is a lock that the utility company puts on. So when they put this lock on, that means that they have sealed it. And this lock is never, ever, ever to be removed because they don't want anybody getting inside here. Okay, I can't think of anything else to do here, so I believe it's time to close this video out. Now, this video was supposed to be a plaster video. We were going to put a top coat of plaster up in the bedroom, but we had an opportunity to fix the deck because the weather was so good, and we thought, well, let's go do it. So we did. All of a sudden, the utility company shows up this morning, and I realized we're not getting anything else done today. So, complete change of plans. I apologize for that, but it is what it is, and we now have power.
I think it looks fantastic.
It does, yeah.
It's really nice to know it's solid again.
Yep, it is.
I love it.
Yep. And so that provides a good solid foundation going forward. The utility company is going to replace the line up there coming out to our pole because it's been chewed through and it's got some problems. They're replacing that. That's all brand new. And now that gives us the opportunity to get in there and start changing out some of the old wiring that's in bad shape.
Ooh.
Especially that above the kitchen.
That'd be really nice.
Yeah, it's pretty sketchy up there right now.
Yeah. Well, thank you for watching 1834 Restoration House.